So we're going to go ahead and get started with Chapter 1 now. So this first part of Chapter 1 is about the periodic table. So you are going to need to memorize several elements from the periodic table. I know this seems kind of annoying. I felt the same way when I was in high school. And usually I don't go into, the memorization just for the sake of memorization. In this case, I think it does have a use, especially as we're going to be using the periodic table quite a bit through this class. So, yeah, this is basically just so that you can see an element name and locate it on the periodic table within seconds. So that'll help cut down a lot of time when you are in tests and using the periodic table and everything like that. So this is really to help you learn how to use the periodic table faster. Yes. So this is the list of the elements that you will need to memorize. We'll split it in half. So the first half, about to right about here, okay, ruthenium, will be the first quiz, and then the second half will be on the second quiz. This is what the quiz will basically look like. We are going to practice this for homework, so don't get too freaked out just yet. So the first half of the quiz, you are going to need to place the atomic symbol in the correct spot on the periodic table. And then for the second part of the quiz, you will need to actually name the elements based on their atomic symbols. Okay? So we'll do some games and stuff like that in class to help you, pick this up a little bit more. Alright, so getting into talking about the periodic table. So again, you will get incredibly familiar with this periodic table in this class. You'll notice that there are several different versions. We're going to look at a couple different versions in this video, but a lot of that just has to do with what kind of information that periodic table is emphasizing. This periodic table is a little bit out of date, maybe like a decade out of date or so. You can tell that because elements 113 through 118 have their ubiquitous names. These names basically just, if you spoke Latin, would tell you what the number is, the atomic number is. They have since been named. I think it was in 2012 when they were named. So there will be a couple of those that you'll see the names of those. This periodic table is focused on the different groups of the periodic table. We'll look at one later that looks at the different types of elements, things like that. So again, it's all based on what type of information the creator of that periodic table is trying to emphasize. So the periodic table arranges the elements by the number of protons in the nucleus. That is what's known as its atomic number. Okay, so it's very important to remember that this is by the number of protons. It used to be arranged specifically by the atomic mass, which is the number of protons and neutrons in the nucleus. We'll get into the guy who changed that in a later chapter, but the periodic table, this version of it is actually really helpful because it arranges elements that have similar characteristics into groups, or columns, and sometimes more than just one column and a little bit mixed up, but basically if they have similar properties, they will most likely be right next to each other in the periodic table. So periods, hence periodic table, these are the horizontal rows. So the similarities along these rows is that they have a similar size. Size will decrease slightly as you go across the periodic table from left to right. They do have the same number of atomic orbitals, and they have some physical and chemical properties that are similar, but for the most part, those will change in a regular pattern across the period. Then you also have families or groups. These are your vertical columns. They have the same number of electrons in the outer atomic orbital. And that is actually incredibly important, as you'll find out through the rest of this class, as that determines the element's reactivity. So elements that are in the same family or the same group, those columns, they generally will react in a very similar manner. Obviously, not exactly identical manner. Generally, the reactivity will either increase or decrease as you go down the family, but that really depends on which family you're looking at. So we've got 4 major types of elements that we're going to talk about. First up, we have the metals. These are probably incredibly familiar to you. So metals are elements that are good conductors and of electricity and heat. So most are solids at room temperature. They are what's known as malleable, so they can be hammered or rolled into thin sheets. They are also ductile, so they can be drawn into a fine wire. So this is where you get like the different metal wires, okay? They also, again, conduct electricity and heat very well. So again, you're most likely very familiar with many of these, such as gold, copper, aluminum. Okay, you could go on. Some metals that you might be familiar with, like steel, are actually combinations of a couple different elements. So we won't talk about those type, but they are, combinations of different metals that give them different properties. So, we also have nonmetals. So metals, nonmetals, pretty easy. So nonmetals are elements that are poor conductors of heat and electricity. Many are gases, so gases do not conduct electricity, thankfully, or else, lightning strikes and the electricity would transfer through the air and then hit anything and everything. So thankfully, nonmetals are not electrical conductors. If the nonmetal is a solid, it is going to be brittle, so it breaks easily, okay, just kind of shatters. They, again, are poor conductors of heat and electricity, so oftentimes they are called insulators. So some examples are carbon, sulfur, phosphorus, and iodine. Okay. So probably a little bit less familiar with many of these, but we'll still see them a lot. You might remember carbon, especially from your biology classes, as it is known as the element of life. Okay. You also have metalloids. So metalloids are kind of the in-between metals and nonmetals. They do have some characteristics of metals and some characteristics of nonmetals. So all metalloids are solid at room temperature. There aren't very many of them. They are what are known as semiconductors of electricity, so they're not necessarily really good at conducting electricity, but they're also not that bad at it. Silicon, boron, antimony, and germanium are all metalloids. So you'll notice that they look like metals. They're like shiny like them. They've got that kind of luster to them, but they are not fully metals. And then the 4th type of element are called the noble gases. This is a very specific column in the periodic table. It is the far right column. Okay. They are the elements in what's known as group 18 of the periodic table. So again, that far right column. They are generally unreactive. They actually got the name noble gas from this unreactive property. Okay, they were seen as basically the royalty of the periodic table, where they didn't want to react with anything. So it was kind of, they were like stuck up like nobles and like royalty setting kind of stuff. They are obviously gases at room temperature, hence the gas part of noble gases. And then you might be more familiar with these than you think. If you think about neon signs, it is actually a noble gas that has electricity forced through it, and that's what makes it glow. So this is where we get our neon lights. And there is a little video about running electricity through these gases. So the gases are generally clear at whenever they do not have electricity being run through them, and then they generally have a very bright color when there is electricity run through them. Okay, so this periodic table, again, I said they would be different based on what kind of information they're trying to show you. So this one breaks down the periodic table based on the type of element. So you can see there are a lot of different metals. In fact, the majority of the periodic table is made up of metals. And then you have this small little section right here that is the metalloids. Okay. Sometimes some people will consider aluminum and polonium part of the metalloids. Other times they don't. Sometimes gallium is included in that. Sometimes it's not. It's kind of weird, but for the most part, these are the consensus right here, that these are the metalloids. You also have your nonmetals. Okay, so again, not all of them will be gases, but oftentimes you will find some of them in a gaseous state. These are also the elements, the only elements that can do what's called diatomic bonding, which means that it's two elements or two atoms of the same element bind together, and that's it. There are no other elements involved. So it's like N2O2, which is the oxygen that we breathe. There's F2, fluorine gas. Chlorine gas is Cl2. Okay, so these are the elements 7, -7, and then also hydrogen. Those are the ones that can diatomically bond. So you've got nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen can diatomically bond. You'll notice that hydrogen is kind of left out of this color scheme. That's because hydrogen doesn't really fit anywhere very well. It is just kind of put over right on top of lithium, just as really a place to put it, not necessarily because it fits there with all of the different trends in the periodic table, but I mean, there's not really a better place to put it. So some periodic tables you will see it's stuck like out here or even more separated from the rest of the periodic table. Again, that's just depends on who made the periodic table. And then over here we do have our noble gases. Okay, you'll notice that this periodic table is really out of date because it's missing a good majority of the last row. Okay, again, just so happens that way. And then you'll also see your groups here. So basically the groups are just going from left to right and numbering each column. So there are 18 groups in the periodic table, so just the columns. Right? And then oftentimes we'll kind of group group 3 through group 12 together, which we'll get into later. Why we do that, and then just focus on 1, 2, 13 through 18. Okay? So that's where this video is going to stop, and we'll pick up with this in the next video.